liftoff of Falcon 9.
It's just before 6 p.m. Eastern Time on Thursday, July 25th, and we're looking at a live view of Cape Canaveral Space Launch Complex 40, where a flight-proven Falcon 9 is about to launch a flight-proven Dragon spacecraft. Now, weather has significantly improved over yesterday, with today's liftoff targeted for 6:01 p.m. Eastern Time, or 10:01 p.m. Coordinated Universal Time. My name is Shiva Bharadwaj. I'm a Falcon integration and test engineer here at SpaceX. Thank you for tuning in for our 18th Commercial Resupply Mission to the International Space Station for NASA. Now, if you watched our webcast yesterday, you know that we scrubbed at about T-minus 30 seconds for weather. These missions to the International Space Station have an instantaneous launch window, so any scrub or abort that will causes us to stand down our launch attempt for the day. Weather is still a watch item today, but currently it's go, looking much better than yesterday. And both Falcon 9 and Dragon remain ready for launch. So at this point, just under T-minus 13 minutes to go. All systems go at Cape Canaveral and SpaceX. Let's take a look at our launch vehicles.
Hi, my name is Michael Andrews, and I work on the supply chain team here at SpaceX. At the top of the vehicle, you can see our Dragon spacecraft. As we mentioned yesterday during the webcast, with Dragon, with some help from Falcon 9, we'll be delivering more than 5,000 pounds of cargo to the space station on this mission, including critical materials to support dozens of science and research investigations that will occur on board the orbiting laboratory. There's a lot of great science going up in Dragon today, and we'll talk about that a bit later in the webcast. In terms of historical firsts, today's mission represents Dragon's first hat trick. This will be the first time we've flown the same Dragon spacecraft for a third mission, as you can see there by the two flight-proven decals on the left side of the vehicle. This particular Dragon visited the ISS for cargo resupply missions back in April of 2015 and December 2017. You'll also notice another decal on the exterior of Dragon, which SpaceX added to commemorate and celebrate the 50th anniversary of NASA's Apollo 11, the world's first mission to land humans on the lunar surface. Directly below the Dragon spacecraft is our Falcon 9 rocket. It is made of two stages. The first stage, which is the longest portion, will power the vehicle through Earth's gravitational pull into the vacuum of space. And once the vehicle is up there, the Falcon 9 first stage will separate from the second stage, return back to Earth, attempt to land, and be reused for future missions. Falcon 9's second stage, which sits just above the first stage, has a single Merlin vacuum or MVAC engine, which ignites after a first stage separation. The second stage is what will carry Dragon to its intended orbit, allowing the spacecraft to eventually rendezvous with the space station in a few days. And Dragon isn't the only vehicle we're reflying today. Our Falcon 9 has also flown before on the CRS-17 mission back in May of this year. You can see it still has some soot on it from its previous flight. And today we'll be attempting to land that Falcon 9 back on land at Landing Zone 1, just a few miles from the launch site you see now. Assuming weather holds up, we should get some great views of and continuous coverage of both the launch and landing out of Cape Canaveral Air Force Station today.
It's just about T-minus 11 minutes to liftoff, and the SpaceX team is currently working no significant issues. A go-no-go poll was conducted at T-minus 38 minutes, and we began loading propellants to the vehicle shortly after at T-minus 35 minutes. At this point, the fuel is loaded, our RP-1 fuel is loaded fully on the second stage and almost completely on the first stage. Our super chilled liquid oxygen loading is underway on both stages, and that will complete at about T-minus 2 minutes to liftoff. In fact, you can see the Florida atmosphere condensing from that cold liquid oxygen along the first stage tank. Now, we're currently also loading helium gas into both of the stages. Falcon 9 uses helium as a pressurant to backfill the propellant tanks as we consume those propellants with the Merlin 1D engines during ascent. Dragon is also in its startup sequence that began at about T-minus 35 minutes when it coordinated timing with Falcon 9's flight computer. It's currently undergoing a series of vehicle health checks with its next major milestone in about 2 minutes when it will transition to internal battery power. The range is currently ready to support today's mission. Earlier this week, they issued safe zones for the air and sea surface around the launch trajectory. and currently both those air and sea surface areas are clear for launch. Weather is also go for launch today. Yesterday we had a hold on weather, but today it looks like a beautiful day at Cape Canaveral, and we're go for an on-time launch for a weather perspective. So with that, our launch team, Falcon 9, Dragon, and the range all reporting green, and at T-minus 9 minutes and 30 seconds, all systems are currently go.
Over the last 7 years, SpaceX has made a total of 19 trips to the ISS, and we're under contract with NASA for a total of 26 of these cargo resupply missions. Today, Dragon will be carrying dozens of research payloads to the space station, including research for the National Laboratory, operated by the Center for the Advancement of Science and Space, also known as CASIS. And as I mentioned yesterday, there are more than 25 payloads included on this mission sponsored by the National Lab, the most payloads that CASIS has sent on a SpaceX CRS mission to date. The National Lab payloads represent a diverse group of research investigations, all of which are intended to benefit life here on Earth. Now let's take a look at some of the groundbreaking research from CASIS that will be on board today's CRS-18 mission.
Investigations sponsored by the International Space Station U.S. National Laboratory are primed for launch on SpaceX's 18th Commercial Resupply Services mission to the orbiting laboratory. When we say that this launch is packed with research, we mean it. This launch has more payloads than we have ever sent on a single mission. Private sector companies, academic researchers, STEM projects, life and physical sciences, all on this mission. So let's get an idea about some of the payloads that are launching on SpaceX CRS-18. The Goodyear Tire and Rubber Company is sending what they hope is the first of many investigations to the ISS National Lab. This initial experiment will evaluate the formation of silica particles in microgravity. Silica is a common material used in consumer tires. However, silica and rubber are materials that don't easily bond. Can the microgravity environment of the space station allow Goodyear to find silica morphologies not possible on Earth? If so, this could lead to improvements in fuel efficiency and other performance factors in consumer tires. The space station is an ever-evolving research platform, and NASA and the ISS National Lab are constantly sponsoring new facilities on the orbiting laboratory to increase the capacity for innovative research. This launch, America's first automated bioprinter for use in space, will make its way to station. Developed by TechShot, this bioprinter will initially seek to print cardiac-like tissue. The printed tissues will remain on station until they are strong enough for the return trip to be analyzed on Earth. While the ability to manufacture human organs is likely many years away, this bioprinter could lead to unique methods of industrial biomedicine and microgravity to develop materials for patient care on Earth. Part of the role of the ISS National Lab is to inspire and educate the next generation. And what better way to do that than by forming fun and exciting collaborations with unique partners? Not many young students understand the term non-Newtonian fluidics in a microgravity environment. However, just about every young student is familiar with Nickelodeon and its iconic slime. So on this mission, Nickelodeon Slime in Space will make its way to station for a variety of demonstrations to educate students on the basic concepts of fluid flow and microgravity compared with normal gravity conditions on Earth. So there you have it. Advanced materials, industrial biomedicine, education payloads, new facilities, and repeat flight partners. This mission represents the demand that continues to build as more researchers and companies recognize the unique potential for sustained R&D in microgravity. To learn more about all ISS National Lab sponsored payloads on this mission and how to become part of the space station research community, visit issnationallab.org.
In addition to the science going up with CASIS, there's another important piece of cargo residing in Dragon trunks today, a new International Docking Adapter, or IDA-3. This piece of hardware connects spacecraft to the ISS. IDA-3 attaches to the Harmony node and can accommodate commercial crew program vehicle dockings, including the first spacecraft to launch astronauts from U.S. soil since the Space Shuttle. IDA-3 is identical to the International Docking Adapter 2, or IDA-2, we sent on CRS-9 in the summer of 2016. And a fun fact, IDA-2 was actually used by SpaceX during our first uncrewed flight test, Demo 1, in March of this year. Later this summer, 2 Expedition 60 crew members will perform a spacewalk to permanently install the IDA-3.
Now we're currently at about T-minus 5 minutes, continuing towards our countdown for a 6:01 p.m. Eastern Time launch to the International Space Station. In these final few minutes, Falcon 9 is performing a series of final health checks on its primary communications, avionics, and propulsion systems in preparation for the flight. As I mentioned earlier, we're currently loading fuel and liquid oxygen into the propellant tanks. Currently, fuel is fully loaded on the first and second stage. Liquid oxygen is nearly fully loaded, and that'll finish up at about T-minus 2 minutes. At T-minus 7 minutes, we began engine chill-in. That's where we put a small amount of super-chilled liquid oxygen into our Merlin 1D engine turbopumps. That prepares them for full propellant flow during flight. And you may hear the announcement that the engines are sufficiently chilled in for launch later on in the countdown. Currently underway are also checkouts of the second stage's Merlin vacuum thrust vector control actuators. Those actuators move the nozzle, which we use during our guidance maneuvers on our way to orbit. Now, you may hear this referred to as our engine wiggle test, and the first stage engines will perform a similar wiggle of their Merlin 1Ds just a few seconds before ignition. Coming up at T-minus 1 minute, Falcon 9's flight computers will transition into startup mode. That's an autonomous mode that will guide the rocket through the rest of the countdown. The SpaceX launch director will give a go for launch at T-minus 45 seconds. And finally, a few seconds before liftoff, the engines are ignited. At T-minus 0, the rocket is released from the hold-down clamps on the pad, and the strongback, which is that truss structure on the left of the rocket, will retract away, clearing the way for Falcon 9's ascent. Dragon is performing a similar series of checkouts at this time to make sure its primary systems are ready for the 2-day flight it will need to rendezvous with the International Space Station. The range and weather both remain go for launch, which is great. So we're continuing on towards that 6:01 p.m. Eastern Time launch. And with that, why don't we take a listen to the nets for the final few minutes of terminal count.
Stage 1 launch load closed out.
Seconds and counting. We've cleared our 2 constraints we were tracking earlier today. Weather's not acceptable for flight. The evaluation of Dragon paint on the trunk section indicates no concerns. Again, now T-minus 2 minutes, 30 seconds, and counting.
Stage 2 LOX load is closed out. Gas close out to starting. Falcon 9's in startup.
Dragon is in startup.
Go for launch.
T-minus 30 seconds. T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
Vehicle is pitching downrange.
And there is successful liftoff of Falcon 9 carrying our 18th resupply mission on a Dragon spacecraft to the International Space Station. Now we're currently in what we call the throttle bucket, and that's because in about 30 seconds we have an event called maximum dynamic pressure, or max Q. That's the point where the vehicle experiences the highest aerodynamic stresses. So what we do is we bring down the engines a little bit, pass through that point, and then throttle back up once the atmosphere continues to drop off above that point.
Vehicle is experiencing maximum aerodynamic pressure.
So now we're through that point of maximum dynamic pressure. Now coming up are a series of rapid events, main engine cutoff, then stage separation, followed by second engine start of the second stage's Merlin vacuum engine, and then the first stage is going to conduct a boost back burn, followed by a Dragon nose cone deploy. Now, main engine cutoff, or MECO, is where all 9 Merlin 1D engines on the first stage will shut down. Followed shortly after that is stage separation, and then a few seconds later, the Merlin vacuum engine on the second stage will ignite to boost Dragon into low Earth orbit. In fact, during ascent, you heard the call out for engine chill-in of that Merlin vacuum engine. So again, coming up in about 10 seconds, MECO, stage separation, second engine start, and then stage 1 boost back burn.
MECO.
Stage separation confirmed.
And back ignition. Stage 1 boost back startup.
And you can hear the cheers behind me. You're looking at a successful start of the Merlin vacuum engine on your right screen and the boost back maneuver on your left-hand screen of the first stage. Shortly here, we should have nose cone deploy off of Dragon, and we may be able to see that on the right-hand screen. And there goes the nose cone on that right-hand screen. We no longer need it now that we're out of the densest parts of the Earth's atmosphere.
Stage 1 boost back shutdown.
Both vehicles are following nominal trajectories.
So in order to make its way back to landing zone 1, the Falcon 9's first stage is going to execute a series of 3 burns. The first of which is the boost back burn. We've just seen that shut down.
Of signal, Bermuda.
It's meant to slow the rocket down and orient it for re-entry. It also helps Falcon 9 laterally return to the landing zone. Liftoff was only a few minutes ago, but we traveled a significant distance horizontally that we want to recoup. Shortly after that first burn initiated, you see some of our titanium grid fins. There's 4 of them. They're located near the top of the first stage. They're deployed at this time and help guide the rocket during descent once the atmosphere is thicker. Now, following that boost back burn, our second burn is executed. It's our entry burn. It's coming up in about 2.5 minutes. It helps the vehicle slow itself down before hitting the dense part of the atmosphere. Failing to perform this burn would put unnecessary strain on the Falcon 9. And lastly, our third burn, the landing burn, happens just before touchdown and takes the booster down softly to land, and our 4 landing legs also deploy during this final burn. For those of you just joining, it's T plus 4 minutes, 55 seconds, and you can see our second stage on its way to drop off Dragon to its targeted orbit on the way to the International Space Station, and on the left-hand side here you see our Falcon 9 first stage on its way to Cape Canaveral, Florida, landing zone 1 for a successful landing. Our first stage had an on-time launch at 6:01 p.m. Eastern Standard Time just a few minutes ago.
Nominal trajectories.
We had a nominal ascent and ideal stage separation. We've just performed the first of 3 burns of the first stage, the boost back burn, and we're a little more than a minute away from that second burn, the entry burn. And so you see the second stage's engine is still burning bright, but on the first stage we've used most of our fuel during liftoff, and we only have so much RP1 and liquid oxygen to make those 3 burns. So instead of firing all 9 Merlin 1D engines, we're only going to fire 3 of those for the boost, back burn, and entry burn, the center Merlin engine and the 2 perimeter engines. We're just about 20 seconds away from that entry burn beginning, and it'll last about 30 seconds all the way to T+7 minutes.
Stage 1 entry burn started.
We've heard the call out. You can see it visually. Our second entry burn has begun and will last for just a few more seconds.
Stage 1 entry burn shutdown.
2 burns down, 1 to go. The landing burn is our
Both
last
vehicles
burn.
continue to follow nominal trajectories.
It'll occur in about 30 seconds, and it lasts for about 30 seconds all the way until landing.
FDS is safed.
You can see Cape Canaveral coming into view. In terms of fuel conservation, we only fire 1 Merlin engine on this final burn, engine number 9, the center engine.
Stage 1 entry transonic. Stage 1 landing burn started.
Our landing burn has begun.
Stage 2 has entered terminal guidance.
You see the landing legs are deploying.
Falcon 9 has landed. Landing operators moving procedure 11.100.
And the Falcon has landed. Congratulations to everyone here at SpaceX for another successful landing. For those of you keeping score, this is our 44th successful first stage recovery. This is our secondary mission at SpaceX. It's our commitment to vehicle reusability. Back to our primary mission.
So back to our primary mission.
Nominal orbital insertion.
We just had secondary engine cut off, and you just heard the call out for a good orbit. That's fantastic. That means that Dragon and the second stage are in low Earth orbit around the Earth. Now, the second stage does have one last major task for today's mission, and that's commanding separation of the Dragon spacecraft very shortly from now. We should have video of Dragon separation from the top of the second stage. And that's what we're looking at the moment. Okay, so shortly here, and now that camera view at the top of the second stage, that looks into Dragon's unpressurized cargo portion. There, you can see it.
Dragon separation confirmed.
Acquisition of signal, Newfoundland.
You can hear the cheers
this is
behind
Dragon
me.
CC on countdown 1. Dragon senses separation.
Off Dragon goes
Thanks
for
for the
its
ride.
mission to the International Space Station. The Dragon team doing a little handoff with Falcon there.
As mentioned previously, Dragon is carrying tons of cargo to the International Space Station on this mission today. A small portion of the cargo represents supplies for the astronauts, things like food and clothing and personal items, but most of the cargo represents science going up to the space station. The ISS serves as the world's leading laboratory where cutting-edge research and technology development help enable human and robotic exploration of destinations beyond low Earth orbit, including the Moon and even Mars. In about a minute, we'll have our final milestone that we'll be covering in today's webcast. It's our solar panel deploy. There are 2 solar arrays located on either side of Dragon's trunk, and at about T plus 12 minutes, they'll begin to unfold almost accordion style over about a minute or 2, and they help power Dragon on its several-day trip to the International Space Station.
This is Dragon CC on countdown 1. Dragon's propulsion system has successfully primed, and all thrusters report ready for firing.
And over the next couple days on its trip, the next milestone that occurs is opening of the GNC door, the Guidance, Navigation, and Control door. There are various sensitive components that can't be exposed to the atmosphere during liftoff that help navigate and help the Dragon understand where it is on its trip to the space station. That'll occur a couple hours after liftoff. But we are about 15 seconds away from solar array deploy. And currently here on the left-hand camera, that's where we're watching for solar array deploy. The solar panels are packed right up against that camera view, and once they deploy, you'll begin to see them expand and see the rest of our gorgeous view here from Dragon as well.
This is Dragon CC on countdown 1. Dragon is deploying its solar arrays.
And we've heard the call out. You see the expansion there. We've successfully begun to deploy our solar panel arrays, which will occur over the next couple minutes.
Dragon is now on its way to the International Space Station. That's going to take 2 days to make it to the International Space Station, and over those 2 days, Dragon will perform a series of orbital height adjust maneuvers with its Draco engines, just until it's a few kilometers away from the International Space Station. Once it's there, it will establish a direct communication link with the International Space Station, and then NASA and SpaceX will perform a series of checks to ensure that Dragon is ready to safely approach. Now once we feel confident, we will initiate that slow approach. And there are several checkpoints along the way where we continue to monitor that we can safely get to the International Space Station. Now, when Dragon is about 10 meters away from the space station, we do need a little bit of help from the crew aboard. The astronauts will capture Dragon using the station's robotic Canada arm in a process that's called berthing. Finally, Mission Control in Houston will send commands from the ground for the space station's robotic arm to both rotate and then install Dragon onto the station's Harmony module. Dragon will remain at the space station for about 4 weeks before it will return to Earth with cargo and research.
And at this point, we will end our webcast coverage for today's mission. To recap what happened, we had a successful launch of the Falcon 9 at 6:01 p.m. Eastern Time. We had a successful stage separation, a successful 44th landing of our Falcon 9 at Landing Zone 1 at Cape Canaveral, and this is the first time a Dragon capsule is heading for its 3rd trip to the space station. Dragon's arrival, capture, and installation to the ISS will be streamed live on NASA TV starting Saturday, July 27th at 8:30 a.m. Eastern Time. Dragon will spend about 4 weeks, like we mentioned, attached to the space station before returning to Earth with cargo and research to send back.
So over the next 2 days, we're going to be posting mission updates on both NASA and SpaceX's social media accounts. So please follow us there if you want to continue to get updates about today's mission. We want to give a big thanks to the Range and the Federal Aviation Administration for their support of today's mission, and a huge thanks to our customer NASA. A big congratulations to them for the 50th anniversary of the moon landing, and thanks for their continued support of SpaceX. Finally, we want to thank all of you, our viewers, for joining us today, and until the next time, we hope you have a great rest of the day.